and not any old forms, but gauge symmetries. Special relativity zeroes the space-time metric to a set of local points under the invariance of the Poincare group of symmetries. But then the inside of these zeroed space-time points can contain something further of their intrinsic spin. Symmetries gauge structures such as the trio of SU3, SU2, and U1 that generate the standard model of particle physics once the vacuum cools sufficiently for such structure to crystallize out and become a thing, a flood of excitations of that form.
So quantum field theory gives you your Platonic structure, and that theory is now mathematically precise and experimentally verified.
You can look to Aristotle and Plato for the basic metaphysics. They were trying to sum up what Greek philosophy had already spent 3 centuries discussing: the logic of the unity of opposites.
Aristotle and Plato were applying that basic dialectical approach to reasoning by trying to boil it down to the fundamental dichotomy of form and matter.
Or what in modern terms we could call information and entropy, global constraints and local degrees of freedom.
This provided the holistic paradigm of 2 complementary notions of being in interaction, mathematics, structure, interaction with material, fluctuation, or in quantum terms, a sea of fluctuation shaped by the emergence of constraining order, the kind of global order made precise by the maths of symmetry and symmetry breaking.
The universe as we now know it. A dimensionality that has the Poincare group structure of a 4D space-time, and then which is filled with the energy of its gauge group local excitations. The bosons and fermions that are generated by SU3, SU2, and U1, as the local spin resonances which an excited vacuum can't help but ring with.
If you fashion a bell that makes a cavity that has to then ring with certain frequencies, and that is basically the universe of 4D space-time cavity that echoes with its own violent shaking SU3 and U1 are the frequencies at which this global whole can resonate in terms of its mix of locally particular excitations.
The Big Bang is the hard strike that starts as a shattering confusion of resonances and then subsides to the low fading hum that we can hear as the state of our 2.7 degree Kelvin universe today.
Technically disappears from sight when the quarks get rolled up into protons. A state of electric charge also gets broken into the weak force as a short-range decay story, and electromagnetism as the photon, which is what is finally left as the final last weak but all-pervasive hum of the void.
That is a considerable simplification of particle physics, but you get the basic idea.
There is no real matter involved, just a cascade of echoing frequencies that lose their energy and become reduced to ever more simplified forms. Quantum excitations shaped by their space-time, container, and winding up, as simple as possible.
The heat death of the Big Bang arrives when all that remains is the eternalized low hum of black body photons with a wavelength that the scale of the visible universe, or a frequency that has a temperature as close to absolute 0 degrees K as it can get, given quantum uncertainty and the holographic principle.